Betelgeuse's shoulder in Orion no longer glows, it winks out. The familiar red beacon in the Hunter's constellation fades to a pale ember. You blink. You rub your eyes, it's still there, but it's dimming, not slowly, not like an old bulb, like a star pulling a curtain over its face. Orion's shoulder loses its fire. Across the world, stargazers pause. They lift binoculars. They frown. This isn't a normal flicker. This is a star dying, or about to explode. The first alert came from the American Association of Variable Star Observers. Amateur astronomers in the Netherlands, then Australia, reported the sudden drop. Betelgeuse, the sky's sixth brightest star, was shrinking. By March 2020, it was a third as bright. The internet erupted. Headlines screamed, "Betelgeuse's last breath. Supernova imminent," astronomers scrambled. The sky's largest, most famous red giant was going dark. Global anticipation crackled like static. The end of a star was visible. Now, teams turned Hubble and ground telescopes. They scanned the star's surface. They mapped its atmosphere. The dimming wasn't uniform. A dark patch bloomed on Betelgeuse's surface, a cold spot. Simultaneously, a cloud of dust drifted between us and the star. Hubble observed the dust cloud forming. It was material ejected from Betelgeuse cooling. The dust blocked light. The surface patch blocked more. Two events. One dimming. Astronomers confirmed the dust cloud's presence by late 2020. The star recovered. By April 2020, Betelgeuse began brightening again. The dust cloud dissipated. The surface patch warmed. The mystery wasn't a supernova. It was a cosmic sneeze, a star expelling its own skin. The dimming was a brief, dramatic cough, not an end, a pause. The great red giant of Orion will explode as a supernova, but astronomers estimate it's still tens of thousands of years away. For now, the star's shoulder glows steadily, bright, as it should. The sky darkened over Orion's shoulder. Betelgeuse, the red supergiant marking the Hunter's right shoulder, dropped to a third of its normal brightness. Visible to the naked eye, the dimming began late in 2019. By early 2020, the change was undeniable. The star's familiar glow, a beacon in the winter sky, had faded. Astronomers watched. The world held its breath. Supernova speculation exploded online. The star's shoulder seemed to dim for a reason. It was not the end. It was a pause. Hubble observed the dust cloud forming. Material ejected from Betelgeuse's atmosphere drifted outward. It cooled rapidly, forming fine dust particles. This cloud drifted between Earth and the star. The dust blocked starlight like a veil. Ground-based telescopes confirmed the cloud's composition. It was silicate dust, common in stellar outflows. The cloud's position matched the dimming timeline. Hubble tracked its movement through 2020. The dust cloud was real. It was the primary light blocker. Simultaneously, observations revealed a dark patch on Betelgeuse's surface. A cold spot, larger than Earth's orbit, bloomed near the star's southern hemisphere. This patch, cooler than the surrounding photosphere, absorbed less light. It was a temporary surface feature, not the star's core. The patch coincided with the dust cloud's formation. Both events happened at once, overlapping. The surface cool patch amplified the dimming effect, blocking more light than the dust alone. This explains the mystery. No supernova was imminent. Betelgeuse is a red supergiant, not unstable. The dimming was a temporary stellar event. The star expelled material, forming dust that blocked light, while a surface cool spot added to the effect. The dust dissipated. The surface warmed. By April 2020, Betelgeuse began brightening. It recovered fully. The star's shoulder now glows steady, as it always should. Betelgeuse will explode as a supernova. Astronomers estimate tens of thousands of years away. For now, it is merely a giant breathing. The dust cloud drifted outward, thinning like smoke in a vast chamber. It blocked no more light after February 2020. Hubble saw its composition, silicate grains cooling to form obscuring clouds. Yet a single cloud alone couldn't explain the sudden third brightness drop. Observers noted the dimming deepened precisely where the surface spot bloomed, a coincidence too sharp to ignore. A cool patch, larger than Earth's orbit, lingered on Betelgeuse's southern hemisphere. It absorbed less light than the star's usual glow, creating a visible shadow. But this patch was superficial, a surface weather event. It warmed and vanished by spring 2020. Its temporary nature ruled out any core instability. A supernova precursor wouldn't fade so cleanly, so quickly. Supernova theorists expected a visible energy surge, neutrinos, a sudden brightness spike before collapse. None arrived. The star's core remained stable. Its surface features, while dramatic, were normal for a red supergiant. Betelgeuse breathes in slow cycles, not violent spasms. The dimming was a single, massive sneeze, not a death rattle. What would settle the case definitively? Continuous, high-resolution monitoring across multiple wavelengths, watching the star's surface for the next century, looking for patterns in its convective cycles. Without that, we'd remain reliant on isolated snapshots. We'd miss the slow, deep breaths of a giant star. The dust vanished. The surface warmed. Betelgeuse returned to its steady glow. It will explode someday, but not for tens of thousands of years. The dimming was a fleeting story, not a final chapter. The case file is closed. The star continues its patient, ancient work. What other stellar secrets might be hiding in plain sight?